Everyone, I'm Sailesh with my teammates Kritachi and Shamal. We are going to present our project Autolog Insight. The goal of the project was to create a system where multiple users can upload logs and get AI insights, making it easier for them to do system health checks and to debug their code. The components in our projects are Flask API to handle user interaction, Redis message queue for async processing, Logstash for log parsing, Elasticsearch for storing past logs, AI service using Grok API for inference, and dashboards for seeing these AI insights. These services are deployed on Google Cloud VMs.
So after looking at some of the software components and hardware components that we are working with, let us look at how they interact with each other. There are these are all the services that are running. So firstly, there is user registration, user login and upload. There is a worker that processes all the jobs that are enqueued into the Redis queue. There is an AI service that generates the insights and a dashboard service that shows all the information and AI insight in a clear and concise manner. And then there is an analysis and any possible fixes that are applicable to the particular log can be parsed using a Logstash service. So our journey begins where the user starts by registering into the system using his username and password using this endpoint called register. Here, the user uh, is assigned a particular user profile index in the Elasticsearch and a dedicated Elasticsearch index called username-logs is created for storing the user logs. Uh, a role is created that allows access only to the particular user and a read access to restricted Kibana features. And by enabling Kibana, uh, there is a dedicated user space and index pattern that is created. And this index pattern is now only accessible in that space. Then, after the registration is done, the user logs in to the system using his new username and password. Uh, Based on these two inputs, a JWT token is generated and can be used in any future log upload requests. Users can now upload logs and receive insights for those requests. The uploaded logs are now stored in an S3 bucket. This S3 bucket stores all the logs in a uh, unique ID or a unique key. This unique key that is generated is stored in the Redis message queue along with a unique ID that Redis creates itself. This helps in load balancing and also asynchronous processing. Then a worker job is responsible to listen to the queue and fetch all the requests that are coming in and and pass them over to Logstash. Logstash is the key component here, which parses the given logs and is able to create structured data out of unstructured log data. This is then given back to the worker job, which is responsible to send it over to the AI service to get the relevant insights from the logs that it has been given. The AI service we use here uses an open source model, Llama 3, where it is prompted to give an answer in the form of an analysis and a fix to the problem. The AI insight is added back into the corresponding document in the Elasticsearch. This makes sure that the user is able to view his log, parse data, and AI insight all in a single place. Dashboard service is the Kibana server, which handles login inherently and communicates inherently with the Elasticsearch API. After logging in, the users can now access their dedicated space. And by using the roles and privileges given to them, they're able to use their privileges to look at the uploaded logs and associated insights based on different timestamps and different time ranges.
Coming to the development process, debugging involved 1. Code level try except clauses in Python to catch API responses and errors. 2. service loggers to get status of services on the virtual machines and their logged information. For testing, firstly, we did component or service level testing to check each endpoint, worker service, and AI service independently. Secondly, we did integration testing to make sure that data was being passed through services as expected. So, for example, to ensure that S3 uploads were properly downloaded by worker. Finally, we did end-to-end testing for one user and load testing for concurrent users. The load in our application consists of multiple users and multiple large log uploads. We tried for up to 100 concurrent users. The registration is the most time-consuming service, but only occurs once in the user lifetime. Coming to potential bottlenecks, each service can be one based on the number of requests, and the solution is to deploy more instances. Logstash parsing can be made more efficient by optimized patterns. External services like S3 or Llama API are subject to user limits and would require paid subscriptions.
This is the demo of our system. So a new user has to register. So I've entered my username and password and I've successfully registered. So now it is asking, do I want to log in? Yes. So I've logged in and my session token has been saved. So do you want to upload a file? Yes. So my file was present at a specified location in my system. And now we can see that my file has been successfully uploaded. Now we can log into our Kibana dashboard. Here we can see that we have our AI analysis. So this was the event from the log, file upload issues, too many connections, log name, UID, EUID. So what our AI analysis has come up with is that the log shows that SSH daemon SSHD has blocked a file upload due to too many connection from the same IP address. The fixed suggestion is that to prevent this, you can configure SSD to limit maximum number of concurrent connections per IP and so on. Thank you.